Hello students, today I am going to take a new topic, that is nomenclature of organic compounds containing substituents and the functional group in them. I hope you remember that functional group: carboxylic acid group, alcohol, ketones, aldehyde, amines and many more. These are the group of atoms which gives the special property to the organic compound, but sometimes some other atoms other than these are also present in the compound, and these are known as substituents. So let me start with the substituents first, because it is a new topic for you. So I'm starting with the substituents, and I'm starting with the halogens. Sometimes halogens are also present in the compound. Halogens are the elements of the 17th group in the periodic table. So these are indicated by the X, and in the same manner as the functional group attached to the alkyl group, in the same manner they are also attached to the alkyl group. Like if I have CH4 and I remove one H from it, I will get CH3, and if I'm adding this halogen atom to it, it will be a new compound having a substituent in it. So I'm taking with the examples. Halogens, we have 4 halogens mainly. We have fluorine, chlorine, bromine and iodine. These are the symbols of the atoms of fluorine, chlorine, bromine and iodine. Other than that, we have another substituent that is called alkoxy group. As the name is indicating, alkoxy group is containing 2 parts, alkane part and oxy part. So let us take it, O and R. As we know, this is R part, which is called alkane part, alkyl group से बना हुआ, and this O is the oxy part. Depending upon what is that alkyl part in the alkoxy group, we'll be naming that alkoxy group. Like if it is OCH3, I'll be naming it as methoxy because it is containing more carbonate. If it is containing 2 carbon atom, I'll be naming it as ethoxy group. And in the same manner, I'll be naming them methoxy, ethoxy, propoxy, butoxy and many more. On the same pattern, we'll have alkyl group, and alkyl group we have already discussed that this is indicated by the R, and depending upon kitne carbon atoms are present in that particular alkyl group, we'll be naming it as methyl. We can name them as ethyl and many more. So this is all about the substituents. We have substituent as halogens, we have substituents at alkoxy group, we have substituents as the alkyl group. So if these are present in the compound, they will also be indicated by you in the naming. So let us first talk about how to name the organic compound. And as I have already discussed, that whenever we have to name the compound, we have to follow a general equation, a basic equation, and that basic equation is this is your basic equation here. This word root, already we know this thing, that this will indicate you the carbon atom present in the compound. This primary suffix, already we are knowing, this will indicate you whether the compound is having double bond or triple bond, or the single triple bond or the double bond in them. This secondary suffix will tell you about the functional group. On the other hand side, this prefix will be telling you about the substituents present in the compound. So this will tell you this is the name of the compound, you will be naming it, and these are the parts of the compound. One by one we will be talking about each part, and we'll be adding them to complete the name of the compound. So we'll start the naming of from the word root. We'll take care of second thing, that is the primary suffix, and then we'll be adding the secondary suffix to it, and lastly whatever is left out will be taken as a prefix, and that is always a substituent. And already we have discussed about substituents will be halogens, maybe alkoxy or maybe alkyl group. On the other hand side, the functional groups may be acids, alcohol, ketone, amines and many more. So let us start with the examples. The first example what I am taking here is alcohols. General formula for the alcohol is ROH. This OH is the symbol for the alcoholic group, and the general naming will go according to the general name, that is alkanols. Let us take an example of the alcohol. I am drawing here a simple alcohol having 3 carbon atoms. Let us satisfy the valency. Let us name the compound. I am starting with the word root first, because always we have to take care of that word root should come first. That is, how many carbon atoms are there? 1, 2 and 3. So let us name this meth, ath and probe. It becomes probe. Just because there is no double bond, triple bond, it is ene, and just because there is alcohol, the suffix has to be used. The secondary suffix for the alcohol is -ol. So let us start with it again. Alcohols are indicated by ROH. They are named as alkanols, and the secondary suffix, a special secondary suffix which will indicate the presence of alcohol in your compound, will be OL. So let us name it. First of all, I have added word root to the primary suffix, and then I am going to add ol to it. This ol is indicating the presence of OH in the compound. Is it clear? Now, if I do something like that, if I make any change in this compound, that is, I am adding this OH by replacing the hydrogen from this carbon atom. So what I am getting here is CH3, CH, OH and CH3. This compound, if I name this compound, I'll get this done. Let us see how many carbon atoms. Probe is indicating 1, 2, 3 carbon atom. Ane is indicating there is no double and triple bond in it, and this OH is indicating the presence of ol in it. So are these two compounds same? No. Here the OH is present at the first carbon atom. It is linked with the first carbon atom, but here it is linked with the 1, 2 and 3 second carbon atom. So if I name them only by showing the presence of ol in the compound, how I can recognize which kind of ol it is, which kind of propanol it is? So always remember, whenever you are giving any of the secondary suffix to the compound, always indicate the location of that compound. Location, that will be given by numbering the chain. Numbering of the chain will be done in such a manner so that you can give special smallest number to your functional group. So if I start naming the compound from that way, 1, 2, 3, my OH will come at the third position. So I will not name the chain in such a manner so that I will give the alcohol third position. This alcohol is a functional group and it is like a guest in our compound. So always give this priority to the functional group. So I will name the chain by considering this as a numbering pattern, and this OH will be there on the first always, and that is why I will be using 1 before the number, before the suffix of that particular functional group. So this 1 ol is indicating that the ol or the alcohol is present at the first position. But here, what is there? There is ol which is present at the second position. So this will be named as propane 2-ol. 2 is the location and ol is the functional group. Hope it is clear to you. Let us name the compound by taking one more example. This is 1, 2, 3. So this is one more alcohol here, and I'm going to name it. How I'm going to name it? By numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. If I move from that way, this is alcohol which is the second position. If I'm starting with that way, I'm getting my alcohol at the fifth position. So I will not be naming this compound in this manner. So how I'm going to number it? I'm going to number it in this way. So start naming the compound by writing the word root. Word root for the 6th carbon is hex. Ane is indicating single bond, and the alcohol is indicated by the ol, but the position will be indicated by the 2. So this compound becomes hexane 2-ol. Hope it is clear to you. But sometimes we see that two groups also in the compound. Let us take one more example in which we will be having a slight difference in the compound, that is 1, 2, 3, 4, 5. I am having OH here and I am having OH here also. How to name this compound? Count the number of carbon atoms. 5 means pent. No double bond, triple bond means ane. And the alcohol which are present on the second and the fourth position, they will be indicating by all, but just because there are two alls, I will be naming them as diol. Where these two alls are present, that will be indicated by their locations, that is 2 and 4, separated by the hyphens. So this is the name of the compound, and as we have already discussed, if we are using any of the functional group, we don't need to use the suffix ane completely. We have to remove this e from the ane. Are you clear? So this is pentane 2,4-diol. Now let us take another example, and that example is the another kind of functional group, and that functional group is aldehyde. These aldehyde are indicated by the general formula, that is RCHO. This is aldehyde group attached with the R group. Aldehydes are generally named as alkenyls. It means al is the suffix which is used for the presence of functional group called aldehyde group. So the secondary suffix for the aldehyde is al. So if we find any of the aldehyde group in a compound, the secondary suffix used will be al. So let us take one of the example of this al, that is, I am drawing one more compound. The compound is having 1, 2, 3, 4 carbon atom, so it becomes bute. The compound is having aldehyde group, but before that we have to consider the double bond, triple bond, it is ane. Compound is having aldehyde group, so it is al. We have to take care of one thing here. If there is aldehyde group or there is one more group called acid group, in both the cases we will be considering these as a part of the chain and we will be giving them only at the first position. So if I am considering functional group as the guest of the complete compound, we will be considering these two groups as a special guest. So if they are special guest, they will always be given at the first position and the chain will be starting always from these compounds, and this is aldehyde present at the first, this is 2 now, and this is 3 and 4. So the name of this compound becomes butane plus al, but just because it has to be omitted out, the name becomes butanol. And as I have told you, this will always be 1. We don't need to always mention 1 again and again under the name of this, against the name of this. That is, if the position of any of the functional group is 1, we can omit the position. And that what I mean to say here is, if 1 is not written, if it is 1, we can omit it out. If it is nothing written out, it means it is a 1 position. Are you clear? So let us take one more example of this kind of compound, that is aldehyde. As I have told you, 1, 2, 3, 4, 5. So it becomes pent. As I have told you, it is ane because there is no double bond, and the name of the compound starts from the 1, and that is al. And this has to be removed, so it becomes pentanol. Hope it is clear to you. Let us take another example of another kind of functional group. The third functional group which I am going to take here is carboxylic acids. Carboxylic acids are named as alkanoic acid. The secondary suffix used for the alkanoic acid is oic acid. So we have to end the name by using the term oic acid. Let us take one example of this compound. I am writing down one example of this. This is the compound. Satisfy the valency. Hope it is done. Name the compound. As I have told you, COOH and CHO. If they are there, they will be considered to be as the special guest. And they will always be given the first position, so we don't have any option here. We have to start naming the compound, the numbering of compound, by considering this as a part of the chain, and I will be numbering the chain as 1, 2, 3, 4, 5 and 6. And just because there are 6 carbon atom, it is hex. Just because there is no double bond, it is ane. If it is a COOH group, the secondary suffix used will be oic acid, so it becomes hexanoic acid. So they are alkanoic acid. Alkane part is indicating the R part of the compound, and the oic acid is indicating the COOH of the compound group. So hope it is done to you. Let us take one more example, that is ethers. The general formula for the ether is ROR dash. This ether is, here it is alkyl group, and here again it is alkyl group. These two alkyl group may or may not be same. That is why I've used the R and R dash here. Sometimes these are same, sometimes these are not same. The secondary suffix, which is used for the functional group, but as I have told you that this alkoxy group is a substituent here, so let me show you how this ether is formed actually. So I'm taking one example, methane, CH4. If I remove one H from the methane, it becomes CH3. If I add methoxy group to it, what will happen? CH3O CH3. Can you compare this formula with this ROR? Here it is R, here it is R dash, and this is O here. So this becomes ROR dash. So we have got this special compound called ether by adding OCH3 to the alkane by the removal of minus H. So this ether is actually formed by the addition of substituents to the alkyl group. So here actually we are not having this secondary suffix. What we have to go for, we have gone through this substituent and we have seen it, this alkoxy group is a part of the substituents. So how the substituents are indicated in the name? These are indicated as a prefix. So now I am going to name this compound by using the prefix, but not that suffix part. Let us name the compound. Let me show one of the compound, that is CH3O CH3. These compounds are generally named as Alkoxy Alkane, and the suffix used for them will be depending upon that how many carbon atoms are present in that prefix, in that particular alkoxy group. So as you can see here, this is one carbon. The alkoxy group will be named as methoxy, and I will be naming the compound in the same manner as we were doing it since starting. That is, one carbon it is present is the compound. This I am considering as a part of the substituent which I have added by removal of the one hydrogen from this CH4. So this was CH4 first. I have removed one hydrogen from it and I have added methoxy group to it. So this is basically a basic chain is of one carbon. Now because it is one carbon chain, I will be naming it as methane. And what is added to the methane? This is methoxy. So I'll name this compound as a prefix, methoxy. So here this is methoxy methane. What does it mean? It means this meth is for the main carbon chain, that is the word root. Primary suffix, that is ane, is indicating the single bond only, and this methoxy group is actually indicating the presence of substituent, what kind of, alkoxy kind of, and just because this alkoxy group is having one carbon atom, this is methoxy. So the name of this compound becomes methoxy methane. Hope it is done to you. Let's take one more example of it with a single variation, with a simple variation. Let us name this compound. The very first thing which should come in our mind is which will be which will be alkoxy group and which will be the alkane. So we have two part here, alkoxy alkane. So alkoxy and alkane, we have two parts. So first of all, we have to decide which we will be taking as alkoxy part, because we have two R parts here. So which part you are taking as alkoxy and which part you are taking as a alkane. So there is a rule behind that. Always remember, this alkoxy group will be the smaller one always. So whatsoever the group, whether it is on the left hand side or it is on the right hand side, consider the smaller group as an alkoxy group and the chain will be considered to be as alkane. And all of you can very clearly see here that this part of the chain, this part of the compound is the bigger part, and bigger part is having 1, 2 and 3 carbon atom in it. So how I am going to name it? Alkane means meth, eth and prop, so it becomes propane. And word root is here prop. Ane is indicating no double bond, no triple bond, and this H here, one H of this CH3 has been removed by OC, has been replaced by OCH3, and what is that? This is methoxy. So I'll be naming this compound as methoxy propane. Are you clear? So the name of this compound is methoxy propane. Hope it is done to you. Let us take one more example of this compound, this kind of ethers. In this particular compound, you can easily see that this is the chain here. And just because this is a chain, I have to number the chain because I have removed one H from this carbon atom and I have added methoxy group to it. So here we have two parts. This is the chain part and this is alkoxy part. So first of all, I have to name this compound. This alkoxy group has to be given the smaller position. I have two options here to number the chain. That is, I can start numbering the chain by 1, 2, 3 and 4. If I consider this chain, my methoxy group is present at the second position. If I consider the chain from this side, 1, 2, 3 and 4, my methoxy group is appearing at the third position. So if we consider this is at the third here and this is at the second here, so I'll go for the option where I'm getting this alkoxy group as the smallest position. So this will not be working here. So I'm not going to take this as a part of the chain, as a numbering part of pattern of the chain. I'm going to take this one as a numbering pattern where I'm getting my alkoxy group as at the second position. So name the compound in the simple manner. That is, what will be the word root? Word root will be decided by the chain. So this chain is having 4 carbon atom and this is the word root. 4 carbon atom means but. Just because there is no double bond, it is ene. And just because it was a big more number of carbon atom, I am considering this as a alkane. So this is butane. What is attached to the butane? This is an alkoxy group. What alkoxy group is present here? Having 1 carbon atom. So this becomes methoxy butane. But one thing is left out here, and that is where this methoxy is present. So as I've told you in the case of the functional group also, if we are considering any of the group present at any of the position, we have to consider that position also, because we can change the position with the different structures. So it becomes 2-methoxy because this methoxy is present at the second position. So it becomes 2-methoxy butane. Hope it is done. Let us take one more kind of functional group, and that is esters. Esters are generally written down as RCOOR'. Here again we have two parts, R and R. And always remember, this part which is attached to the carbon atom will be considered as the chain, and this another part which is a separate out part, this will be considered as a alkyl group. So let us write down, let me tell you how these are named as. These are named as alkyl alkanoate, what they named as alkyl alkanoate. As I've told you, alkyl group is this part and alkaloid is the main part. Let me tell you this by taking some example, and that example is, so this is your compound. Let us name the compound. First of all, I have to decide that with which carbon atom, with which chain the ester group is attached with. So this is your main chain here. So this main chain is containing how many carbon atom? 3. So it becomes prop. And this is the main chain here. So this is propanoate. It becomes propanoate. So this OH is indicating the presence of the COOH group, which is always added as a secondary suffix, and this A here is indicating that there is no double bond in between. So basically we are starting with the word root prop with the primary suffix A with the secondary suffix OH, actually OH. So this is propanoate. What is left out is this part, and as I've told you, this is the alkyl group. Which alkyl group is present, having how many carbon atom? 1 carbon atom. So it becomes methyl propanoate. So the name of the compound becomes methyl propanoate. Hope it is done to you. Now let us take another example, another kind of functional group, and that is ketones. Ketones are the very important category of the organic compound, and that is represented by R, C, double bond O and R dash. This R alkyl group, this R is again alkyl group, which is added, which is linked to both the side with the carbon atom, which is one-sided linked with the oxygen. So let us see how to name them. These are named as alkenones. It means the secondary suffix for them is -one. How they named as -one. So this is why, this is how we have to name the ketones. Let me give you one example of this ketone. See to the compound and number it. 1, 2, 3, 4, 5 and 6. This is a chain of the compound. The another option is 1, 2, 3, 4, 5 and 6. If I number the compound from this way, I am getting this ketonic group. This group is known as ketonic group. I am getting this ketonic group at the 3rd position. If I number the chain from that way, I am getting this ketonic group at the 4th position. So as I have told you, the functional group are the guest of your compound. So always attend them as early as possible and give them the smallest position. So this is the way we are going to number it. So this chain will be working and this chain will not be working here. So I have to rub it out. Let us name the compound. The compound becomes, starting from the word root, how many carbon atoms? 6, means it is hex. What is the double bond, triple bond present here or not? No. So this is ene. Is there any functional group present? Yes. Which one? Ketone. What is the secondary suffix for the ketone? Is -one. So hexane -one. Where this -one is present, it is at the 3rd position. So it becomes hexane 3-one. Simply you can name it as hexane 3-one. Let me give you one more example of this compound. Look at the example. How many carbon atoms are there? The chain becomes this. How many carbon atoms are there? The carbon atoms are 1, 2, 3, 4, 5. So it becomes pent. What is the second primary suffix? Because there is no double bond in between, the primary suffix will be ane. What is the secondary suffix here? Depending upon which functional group is present, it is ketone. So the secondary suffix will be -one. And just because if I am taking the numbering pattern from this side or from that side, I am getting it at the 3rd position. So my -one will always remain at the 3rd position, and I will be naming it as pentane 3-one. Both the ways are correct. I can number the chain according to both the ways. So this is pentane 3-one. Hope it is done by you. So let us take one more kind of functional group, and that is amines. Basically, amines are taken as a derivative of ammonia. If I consider ammonia, what is ammonia? It is NH3. If I remove one H from the ammonia, what will left out? NH2. If I add R group, if I add R to it, what will be there? RNH2. So this is called amine. Amines are categorized as primary amines, secondary amines and tertiary amines, and we will be naming them in the different patterns. This kind of amine which is attached with the single carbon atom to the one side only, that amine is known as primary amine. So let us name the primary amines first. The example of the primary amine is, as you can see, this is the chain and this is your amine group. So this amino group is linked with the R part. So this is your R and this is your amino group. We'll be naming them as alkanamine. I'll be naming them as alkanamine, where the alkane is indicating alkyl part and amine is indicating NH2. They are primary amines because this amine group is attached with the one carbon atom only, and they are named as alkanamine. Let us name this compound with the first starting with the word root. How many carbon atoms? 4, means it is but. No double bond, no triple bond means ane, and just because this is a amine group, it is butanamine. Can you see anything else which is not mentioned in the name? No, we have mentioned this chain, we have mentioned this group, we have mentioned the double bond, triple bond. Prefix already it is not there, nothing is there as a prefix. So the name of this compound is butanamine. Let us understand how to name the another kind of amines called secondary amines. Basically, secondary amines are 2-degree amines, they are called as, and they are named as N-alkyl alkanamine. How they are formed? Let us talk about that first. I have made RNH2 by the removal of one H from the ammonia. So this was RNH2. If I remove one more H from the NH2, what will left out? RNH. If I add one more R to it, what will be formed? RNH. R dash. So this is called secondary amine. I can write down one example here. Let us understand it by taking one example. CH3, NH and CH3. Here it was ammonia before. I have removed one R, making it NH2. I have added one CH3 to it, and later I have added, by removal of one H, I have added one CH3 to it. So it becomes CH3NH CH3. Now while naming this compound, we will be considering one part as a chain and one part as an alkyl group. This alkyl and this as a chain. Why this alkyl, this as a chain? That will be depending upon, if they are same, you can consider any of the part as an alkyl group and any of the part as a chain. As I told you, this is named as N-alkyl alkanamine. So N-alkyl means N-methyl, which is indicating that with the N, methyl group is attached. I can draw it for the better understanding. I can draw it like that. N has 3 valencies, 1, 2, 3 part. With the N, one alkyl group, yeah, one methyl group is attached, and this is methanamine because this is one carbon atom which is attached to the actual amine. So this is methanamine. Hope it is done. I'm starting with this N-alkyl alkanamine. This is N position pe, this is alkyl group which is methyl here, and N position pe methyl is replaced in the case of the methanamine. So it becomes N-methyl methanamine. Let me take one more example so that to better make it very clear to you. Another example is, if the condition is of that kind where one group is bigger one and one group is a smaller one, in that case we'll be taking this bigger one. What can? Bigger one, bigger group, bigger alkyl group attached with the N will be taken as an alkanamine. So I'm taking it as alkanamine, and the smaller one will be taken as N at the N position alkyl. So the name of this compound becomes, the bigger one is having 1, 2, 3, 4 carbon atom, so it becomes bute. Because it is having no double bond, triple bond, it becomes butane, and just because it is a amine, it is butanamine. And this part, which is the alkyl part, will be indicated by the alkyl group, which is 2 carbon alkyl group, so it is ethyl. But where this ethyl is present? With the N, so this is N-ethyl, so the name becomes N-ethyl butanamine. I can name it as N-alkyl butanamine. Hope it is clear to you. Now let us take the third kind of amines called tertiary amines. Let me tell you once again how the tertiary amines are formed. Primary amines by the removal of H and addition of R. Secondary amines by the removal of another H and addition of another R. The tertiary amines by the removal of left out H and the addition of another R to it. So it becomes tertiary amine. So here it is R, R dash and R double dash. R dash and R dash double dash are only indicating that these R groups may or may not be similar to each other. Let me take you to the another example, and that example is CH3, CH2, N, CH3, and here it is CH3. So these are generally, this is one of the example. Here it is R, this is R, and this is R. These are linked to all the sides with the carbon atom. So this is called 3-degree amines or tertiary amines, and they are named as N-alkyl alkanamine. Now I am going to take this particular example to name this compound. This bigger chain will be taken as a alkanamine. Always select the biggest one and take it as a alkanamine. These two are the smaller one, and they will be considered as alkyl and alkyl group. And now we name the compound alkanamine, means we will be starting with the word root. How many carbon atom? 2, means eth. No double bond, no triple bond, ane. Primary suffix ane. Secondary suffix functional group amine. So this becomes ethanamine. Now what is left out is this alkyl group which is attached to the N, and this alkyl group which is attached with the N. To name them as, which is that? N-methyl and N-methyl. So the name becomes N-methyl ethanamine. So students, we have discussed many of the functional group today in detail, but there are only 4 functional groups which are in your course if you are in the 10th standard, and these functional groups are alcohols, acids, aldehydes and ketones. One more group is there in your syllabus, that is esters. Although the naming of these esters are not required so much, but if you are very conscious about the naming, you can go for this esters naming also. Otherwise, rest of the functional groups which we have discussed today are not in your syllabus, so don't go for these if you are in 10th standard. So this is all about the functional groups and the naming of the compounds having functional groups and the substituents. If you have any kind of queries, please comment on the comment section given below. Thank you.